For the past month, I've been remaking the building, editing, and resource harvesting system from Fortnite. In this video, I'm going to give you a technical breakdown of all the key features of my system. But let me be clear, this is not a follow along and blindly copy what I'm doing tutorial. If you want to use this system, you can download it completely for free. There is a link to that in the description. The point of this tutorial is to teach you something new about game development. It's for you to understand key concepts, ideas, and techniques that will make you a better game developer. If you are similarly minded and want to join me in learning game development and help each other, then you can join my Discord server, which is all about game dev and a place where we can all share our progress and learn game dev together. I have just started it with the launch of this video, but hopefully we can grow this community together. Okay, let's get into the system. On the screen you will see timestamps for each key section I'm going to cover, so you can skip to specific ones if you wish. Let's start with resource harvesting. In Fortnite, you can hit 3 types of materials. Ones that give wood, brick, or metal. It doesn't really matter what the material looks like because you can set it to give any one of those 3. I think I have exactly replicated this system by using this very modular blueprint. This BP based material is an actor that you can place into the world and change its health, mesh, material type, and how much it gives per swing. This means that you can place it into the world like so, click on it and change these variables and they will automatically update. So you can use this one blueprint to make all your harvestable materials. Anything you have the mesh for, you can make it into a material. This is how it works. I created a structure to hold all of these variables together in one place. A structure is basically a variable to contain other variables. It's just one place that can hold all of them in the same place for convenience. Although you could technically go without it. Then, in our material blueprint, we create a variable of this structure type, making sure to set it to instance editable and expose on spawn by checking these 2 boxes. This means that every time we place a copy of the blueprint into the world, we can edit that version's structure variable. This is all well and good, but we haven't actually done anything with those variables, so to constantly update the mesh, we can set it in the construction script from this variable. The construction script runs before the game has even started. So as soon as you change something, even before play, it will update, so this function will be run. In short, we create one generic blueprint with a structure of variables that is set to expose on spawn and instance editable. Then we can update its mesh to the mesh variable from this structure in the construction script. The other variables don't need to be updated like the mesh because they get changed as soon as you set them. It's just that the mesh needs a function to actually have an effect, but if you printed a string of the mesh variable, it would tell you the correct mesh. Now that we have our harvestable materials, we actually need to harvest them. To do this, we need a way of telling our harvestables that they have been damaged by our player, which will then trigger some logic to remove some of its health and send the harvested resources back to the player. The Unreal Engine has a built-in function which is absolutely perfect for this, and anyone who wishes to master the engine needs to absolutely master using such functions. That function is apply damage. This apply damage is something that we can call from the player with every pickaxe swing and simply input the amount of damage and the damage causer. You need to give this function a target, so what or who is actually taking that damage. And whatever the target is will then receive an on-take any damage event, which gives you access to how much damage was sent and by who inside of our target. So in our harvestable blueprint, we can say that when we receive damage, we subtract that damage from our health, and because this event tells us who damaged us as well, we can send the materials back to that person, the player, which is simply setting the new brick amount to the old brick amount added to the harvested materials. So brick amount, add 10 brick, for example, or wood or metal. Now, there are 2 ways of sending this updated resources event back to the player. The easy way is to say cast to BP underscore third person character, or whatever your character is called, and you can get the building component out of that reference. The second way, which to be honest is still easy when you know about it, but it's better, is to check if the actor has the build component, and if it does, if it's valid, use the component from this reference. I think understanding casting and why it's considered as bad is very important, as most quick 5 or 10 minute tutorials will use casting, so if you watch lots of these sorts of beginner tutorials, you may set in bad habits. So I'm going to explain what casting is and why you should avoid it. When you cast to a variable, for example the player character, you are loading the entirety of that variable, which takes a lot of computational resources. Imagine you only want to know one variable, the health of the player for example. If you cast to your player, you're not only loading the health variable, but everything else you might have there, the stamina, the mesh, the weapons, etc. So it's usually best to avoid casting for better performance. A very common way to avoid casting is with interfaces. An interface is a collection of functions, but you don't say what the functions do in the interface, you just add the inputs and outputs. The logic for each function is defined inside whichever actor is implementing that interface. For example, if you add an interface to something, the function names will pop up on the side. If it's a function with inputs, it will be golden coloured, and if it's an output function, so you are just returning something, it will be greyed out. So going back to our health example from earlier, what you can do is create a function in the interface with a float output of health. Then go into your character, add the interface, and click on that output function. Here you can just return the health. So now, if you say get player character from another blueprint, instead of having to cast to your player, you can search for the function you made and you'll be returned the health you inputted. This is so much better for performance, as instead of saying, hey, load the entire player and then find what we need, we are just looking for the one variable. Okay, back to our system. Let's discuss how we set up the player's pickaxe. To get the pickaxe in the player's hand, I created a socket, placed it on the mesh, then said on event begin play, add the pickaxe, which can be changed to any mesh you have, to this socket. A socket is a point on a skeleton you can create and move around which you can connect things to. It means that this added object will move and turn with your player. Then, using an input action on left click, play this montage, so this animation, which has an anim notify or an event trigger at the point of the animation where we want to do the damage logic. When we hit this notify, we do a sphere trace from the character to where they are looking a little bit in front of them. If we hit something with this trace, we simply use that apply damage event we discussed earlier. This will fire to our build structures as well, so our walls and ramps etc. But they don't have any logic to increase the material count, as that's all handled on the harvestable material itself. Finally, the last thing worth discussing in this section is getting the weak point to spawn. Essentially, when we hit something, we get the location of that hit and add some random direction either up or down and spawn the weak point. You may see a glaring problem with this idea though. If we hit near the top of a material and we happen to add some height to the weak point, it will be floating in the air. To counter this, as soon as we spawn in the weak point, I do a reasonably large sphere trace around it to find a contact point with the material, and then update its location to be on that point. When we swing our pickaxe, we can check if we hit this weak point as well. If so, we can double the resource harvest and damage applied. Of course, if you want to delve deeper into any of these ideas, you can download the project files and see for yourself exactly what I have done. There are no charges to download it, the link is in the description. Now for the building part, which is probably why most people are here. We can enter build mode by pressing B, which will unequip our pickaxe and spawn this preview build in front of us. By pressing 1, 2, 3 and 4 on our keyboard, we can switch between the wall, ramp, floor and cone. And with a left click, we can place the build. The preview will turn red if we are trying to place it somewhere where it is not attached to anything, as in Fortnite, you can't have builds floating in the air. And finally, if you destroy a build, all the attached builds which are no longer grounded will also be destroyed. To spawn the build preview, as soon as we enter build mode we fire a timer, which triggers every 0.05 seconds, and we spawn the build preview of the currently selected build type. The build preview is simply an actor blueprint which has a static mesh of the shape I want it to represent, for example the floor, but its collision is disabled and its material is set to this blue one. I have kept store of which build we are on with this enumeration, which is just a list of our 4 types of build. It gets updated with these events. An enumeration, or enum for short, is a very commonly used item which is just a list of options that you define and helps to better organise what you're doing. Here, the enum is perfect for keeping track of what build we're on, and it also comes with a switch function. This is a very important function that I've used a lot here, and you can use it by dragging off your enum and saying switch on, then the name of your enum. What this does is it will only go down the execution of whichever item you are on. So if your enum is set to wall and this switch event happens, only this top line will fire and nothing else. Every time the timer fires, we call to this function, which does a bunch of calculations to find the location and the rotation of the build preview. We want it to snap to a grid-like pattern and only increment rotation in 90-degree increments like Fortnite. To do this, we divide the Z rotation by 90, round it to the nearest integer, then times it up again by 90. This basically rounds it to the nearest 90-degree increment, and it's the same idea for the location. By dividing by 400, rounding, then multiplying up by 400 again, we are essentially rounding to the nearest 400 cm cubed, which is each grid tile size. But how do we check if it's grounded, or that it's not overlapping another object? To do this, I use lots of box collisions around every build preview and every build. These build previews are just actors with collision removed, and with these box collisions we can check with each one for specific things, like is it attached to something, which would make it grounded, or if this one is triggered, we know that it's overlapping something too much. Essentially, if this box is overlapping something, then we know that we are very close to another object, so it's not just floating in the air. But if this box collision is overlapping, then we know that the build is overlapping something and it shouldn't be placed. When we detect that the build preview cannot be placed, we set its material to a new one, which is exactly the same but with the colour red. We can make the build preview go in front of the player where they are looking by doing a line trace just in front of them. There are a couple of cases though where this doesn't exactly work. For example, if we are looking directly up, we want the floor to be placed just above us, but in the same grid tile as us, not in the next one along. And if we are looking down, it's the exact same thing. We don't want it to be in the next one down, but in the same tile, so within the same 400 cm cubed. So, what I did was I checked if we're looking straight up or straight down and shorten the line if we're doing so. This makes the line trace end in the same grid tile as us, so our rounding calculations give us the preview in the correct location. These calculations mainly consist of checking the forward vector of the line trace, so it's forward going direction, against the up vector of the world, so a point that is always pointing upwards regardless of the player. The dot product function will compare our two vectors and return a number between -1 and 1, which indicates to what extent they're in the same direction. 1 is for parallel, 0 is for perpendicular, and -1 is for the opposite direction. But of course, it can also be any number in between. Because we do so many checks on the build preview, it's quite simple to place the actual build. We can just destroy the preview and spawn the new build in the old preview's place, using the same grid snap and snap to rotation functions as before, just to be extra sure that it's in the grid. The one thing though that caused me loads of problems was destroying the build and having it destroy the rest of the chain when not grounded and leave it when it is. The final correct version, after a lot of failed attempts, goes like this. We have a box collision around each build, which is quite large to find all the attached builds. Then we add all of these to an array of builds. Now, we have a list of all the builds within one build chain. Then, we loop through all of these builds in the chain and check if it is directly grounded. That doesn't mean touching the ground, it just means touching something that isn't a build itself. To isolate the builds, I gave all of the builds a tag called build, and when checking the nearby area with a box collision, I said to just ignore them if they have this tag. Then, we put all of our grounded builds into an array and we keep looping through them, adding all of their adjacent builds to this grounded list. As if you are directly touching something that is grounded, then that also makes you grounded. We keep repeating this until we do a loop where no more grounded builds are added. Then, we loop through all of our grounded builds and set a isGrounded variable to true, so that for our final loop through the builds we could destroy each one, assuming it's not grounded. Then we reset all of the variables ready for the next loop. You will see though that each build gets destroyed with a short delay in between. You might assume that for each loop of the for each loop I just added a delay, but if you assumed that, you would be wrong. Which is exactly what I thought initially, so don't feel too bad about it. But the problem is, a for each loop is fired every frame and ignores all delays. It's like a function where you just aren't allowed to add delays. So instead of destroying each actor from my component, when it's time to destroy them, I send a call to the build itself where the build will self-destroy after an inputted delay. If we don't do this, if we try and add a delay within the for each loop, they all get destroyed instantly. Let's talk about editing. This final section is probably where most people would have stopped. You can find quite a lot of tutorials on simple building, but I couldn't find any on this specific subject, so I was determined to be the first. Similarly to building, we also have an edit mode, which once again will unequip your pickaxe and get rid of the build previews if needed. When in edit mode, when you press E, you do a line trace in front of the character to find the build in front of them, if there is one. Then we check if that build is either a wall, ramp, floor, or cone. The edit preview, which is again just an actor, will depend on which build we are trying to spawn, but all the edit previews are made up of these individual tiles. Each edit tile is its own tile independent from the others, which is very important for selecting our tiles. And I also made all the builds see-through when editing because it looks a bit cooler, which was just a case of messing around with some of the opacity values in the material. I was able to send the float value that I wanted the opacity to be in the material by using a scalar parameter. A scalar parameter is a node that you can create and name. Then, from outside the material, you can update the value of the parameter by just simply referencing its name. Each tile has a isSelected variable, which when we select the tile changes from true to false or false to true depending what it is already. Then, upon pressing F, we'll loop through all of our tiles and get this variable and add it to an array of booleans, so we now know how many selected tiles we have and how many unselected tiles we have. A very important detail is that the tiles always get added to the array in the same order. So if we select the same pattern twice in a row, we will always get the same order of booleans in our array, which is vital for finding out which edit to make. The ramp actually works slightly differently, but I will go back to that as the end as to not confuse things unnecessarily. Okay, so now we have selected our tiles and confirmed with F, we have this list of boolean values, so a bunch of true and falses to represent all of our tiles. Because these are all in the same order every time, we can check what pattern it is with this function. This looks very messy, but we are just checking each possible combination of true or falses against the one we have to see if we get a valid build. Let me give you an example. For the wall middle window, we check if our list is 4 falses, then 1 true, then 4 falses. If it is, we can just return that our edit is to make the wall middle window. It's the same idea for all of our edits. We actually use another enum to store the lists of all the possible edit choices and another switch node to spawn each one. Then now we know which edit to make, we can just destroy the build, saving all of its variables like the health and material type and spawn a new build that's in the shape of the edit, and add all of the old variables to it. Now I did say that the ramp works slightly differently, and that's because instead of storing booleans, it stores integer indexes. This is because for the wall, floor and cone, it doesn't matter which order we select the tiles in, but for the ramp it does, because if we select the left 3 starting from the bottom, it will make it go forwards, but if we select the same 3 starting from the top, it will reverse the shape. Everything is the same, except we don't have a list of booleans to compare to, but indexes, because we can give each tile an index when it's selected, so the first tile gets 0, then the second one, and so on. We can reuse the whole check if grounded then destroy function from earlier every time we confirm an edit, because if we change the build so that the adjacent ones are no longer connected to a grounded build, then they need to be destroyed. But this was just reusing the same process as before each time, so it's actually not that complicated. There are 2 little bonus functions that I made, which aren't in any of those categories really, that's repair and upgrade builds. These are quite simple from a technical point of view. We can do a line trace in front of us to find the build we are looking at every time we press R. Then, if the build's not at full health, we do a little calculation to see how much health it needs, and how much that costs. Then, if we have enough materials to meet this cost, we subtract it from our resources and update its health. The upgrade builds is a feature from Fortnite Save the World, not Battle Royale, but I thought it was quite a good little addition. Using a line trace again like for repair, we can find the build in front of us when we press G. Then, if we have enough materials, we can change the material of the build and give it a little bit more health. So there are now 3 levels of strength for each material, each giving the build more health. For example, you can see that there are 3 levels of wood, level 1, level 2 and level 3. Each of the meshes are slightly different, but each of them have slightly more health. And that's it. That's a 1 month of work in just a few minutes. Of course, I skipped over some minor features that I didn't think were particularly worth talking about, but as I've said, maybe too many times at this point, but for the last time don't worry, the project files are free and can be found in the description. And if you have any questions about the system, don't forget to join the Discord server I've just started, where I'm hoping to build a community around game development. and I would be very happy to go through things in more detail over there, or just to chat, to be honest. I hope you learned something from this video and now have a better understanding of some of the slightly more advanced game dev ideas. Next time you play or see Fortnite, you can say, I know how that works. Thanks for watching.